In 5, 4, 3. And welcome to another Zach Johnston class. Steve Johnston. I'll be watching this on YouTube 10 years from now and be like, who's the Zach Johnston guy talking in the background? That's a new record. Here I'm over here doing the 5-board. For crying out loud. Anyways, he's going. All right. Sample test 8 today with my live studio audience. Anyway, let's discuss 1 through 13 and see if you have the correct answers. Make sure you know what you're doing. Only have 2 answers. I don't think I was at 2. You didn't answer any farther than that.
I had to write a paper this week.
And I gotta figure out.
And I gotta write one tonight.
A little bit of procrastination.
Got mine with me.
Sorry.
Yes, reminder, make sure you bring the papers in tomorrow. Don't forget that.
Got my boxes ready.
All right. Start 5, 4, 3 over there. All right. Anyway. Okay. So, some of you kids have all these pins uncapped. Not you kids, but it was actually calculus kids. They're all like uncapped and drawing out. This is all on camera. Uncapped my markers. Okay. Anyways. All right. So let's start with the first sequence. Okay. How do we get from?
That marker's dead. You won't be able to see that on YouTube.
It was brand new until somebody left it uncapped. All right. So how do I get from each number to the next number in the sequence? Divide by 5 on each step. Okay, so that's part of that pattern. As a matter of fact, this is an arithmetic or geometric? This is a geometric sequence. How do we know? Only if you are multiplying is it geometric, and this is multiplying by 1/5, isn't it? Right? So that counts. So this is most definitely geometric. Now it's also something else very important. As you notice, the numbers are dropping lower and lower, but by less and less. And this is convergent because it's not going to go down to negative infinity, is it? It's leveling off, right? And it's getting closer and closer to 0, but it never gets there, does it? So that is convergent. Okay. A little note to self. Now, you didn't have to do that, but then later on in those other problems that we all refer to as 7 through 9, we're going to have to go back and look at this, aren't we? Right? Okay, so you can make a little note to yourself while you're doing the test. All right, so if we divide by 5 in each step, let's see, we're trying to find the next term. So the next term in the sequence, how do I divide 2/5 by 5? How about multiply by 1/5, and it was 225. Can we get that? Okay, that's the next one. All right, now we have number 2. Okay, in number 2, we have 50, 40, 30, 20, 10, etc., etc. Aha. What are we doing this time?
Subtracting 10.
We are subtracting 10. Okay, minus 10, minus 10, minus 10. All right.
Minus 10.
Yeah, we're going to get some minus 10s in a second. All right, so, the sample test isn't even on your desk right now. I mean, what do I do with you, Steve Johnston? Yeah, follow along. Of course, you were here yesterday, so I guess you were right. And you were pretty sharp, yeah, that's right. Try to follow along if you can. And try to inconvenience you. So, it's on camera. This is one of those days. All right. Anyways. All right. So take away 10 every time. So this is a what type of sequence?
Arithmetic.
This is definitely arithmetic. Spelled the same as arithmetic, right? But arithmetic. That would be referred to as a heteronym. And if Anybody ever heard of a heteronym before?
Like flower and flower?
Where it's spelled this, no, it has to be spelled exactly the same way, but pronounced differently.
Like read and
Like
Okay,
read.
yes, like read and read, nice one.
Like
Very nice,
That's
Stephanie
just-
Roberts. All right, so now wait a second. It's only arithmetic though if you're doing what? If you're adding only,
You're adding
that's not addition.
You're adding
If you're adding negative 10, it's still arithmetic, sure. All right? Now, the next part of this, boy kids, that sure is getting lower and lower and lower.
Get 'em busted.
I guess it'll just level up at
No.
0. If you keep subtracting 10 forever, eventually you're going to reach what? Or let's say go that direction, you can't ever get to infinity, but it'll eventually reach negative infinity, so therefore it is most definitely what? Divergent. Okay? It can't converge unless it gravitates to one certain number. And that's the one anyway, just going down. Alright? So, the next term of the sequence would obviously be what? 0. Yeah, that's this one. Alright? Now, if you try number 3, here's a good marker. All right, number 3 says we have 1, 2, 6, 15, 31. Okay, if you had this sequence and you had to judge the distance between them, or how you got from the previous term to the next term, how do you get from 1 to 2? Plus 1. How about 2 to 6? What about 6 to 15? You know what? These look awfully familiar here. Plus? Yes, indeed. These are very special numbers because they are the what?
Squares.
All perfect squares, right? So the next one would be plus 25, yielding an answer of 56. I'm going to get that 56 there. Okay. All right. Nice. A little bit more sophisticated pattern there. All right. Okay. This is one type of sequence. Arithmetic, you're adding, and you keep adding those numbers on. Guess where it's going? Infinity. Positive infinity this time. So that is most definitely divergent. All right, there's that one. Okay. Oh, by the way, let's dash on down to number 9 right now. Which sequence in number 1 through 3 is convergent? Hey, number 1 is.
Is that always right?
Just number 1. Yep. Just put that. All right. What else do we have to use here? Oh, I tell you what. While we're at it, let's do number 10 because number 10 relies on sequence number 3. So let's talk about that too. Okay. So on number 10. You had to write a recursive formula. Now, a recursive formula is always based off of what? The previous term, right? How did I get from the previous to the current, right? So, now one like this is an easy one to do recursive. Because this one you just say, okay, if I had a random term a sub n, it would be the previous term. What's the previous term to this? A sub n minus 1 is the previous term, right? Minus 10. So this one would be an easy one, right? You just take away 10 to get to the next one. Okay? This one's a little bit more challenging though. Look at this one. My goodness gracious. There goes one.
It's like he's allergic to math.
Is this every class son, or is this just
It's every class.
Every class? Okay, so it's not just this class. Otherwise it'd be one that was like asbestos in here that's killing me or something.
History lesson.
All right. Okay. Now this one is a little bit more sophisticated. All right. Let's see who got number 10 right because you got to think about this one. All right. So let's say that this is like a sub 5, a sub 4, a sub 3. Next one would be a sub 6. Okay. Let's just pick a random one here. Let's pick a sub 4. If you were to describe a sub 4 and it's recursive, that would come from, if it's recursive, where do I go next? The previous term, a sub 3, and then plus what? I did the previous term plus 9 to get to a sub 4. Okay? It's actually a pattern within a pattern here. A sub 5. The a sub 5 term was the previous term, which is named a sub 4 plus what? Plus 16. Okay? If I went to the a sub 6 term, which was the next one we got, which was 56, right? That was the previous term plus what? Plus 25. Okay? So to do, all these are perfect squares, right? Okay, so if you want to put it all together, the nth term would be the previous term plus, now, for step 6, I have to get 5 squared. For step 5, we have to get 4 squared. 4 is 3 squared, so it's n minus 1 quantity squared. Okay, anybody get that one, by the way? Okay, that's a pretty sophisticated one then. So you got that one, you're a code cracker. All right, good for you. Top of your game. Okay. All right, so recursive, just make sure you tell me how you got from the previous term to the next term. That's all you have to worry about there. Okay? All right, so that's number 3. Okay, so let's go back to number 4. Or yeah, that's number 10. But.
You're confusing me.
And don't forget to put the a sub n as part of your equation.
Would that be a -1?